everyone, welcome. My name is Faith Miller-Lakowitz, and I'm the Education Coordinator here at the McAuliffe-Shepard Discovery Center in Concord. And today I'm going to be talking to you about a mission that just launched about, when you watch this, it'll be a month ago on July 30th, 2020. It's called Mars 2020, and I'm really excited about it. So we're going to jump right in. Now, I have a presentation that I'd like you to be able to see here. Some visuals. So I'm going to move my face over to this side. I'm going to let you look at my slideshow here as I go. So again, we're talking about Mars 2020. Now, Mars 2020 is just one mission within this larger NASA program called the Mars Exploration Program. It's been going on since the 1990s, so this is a long-term effort with many missions, and we're kind of taking incremental steps to eventually get people to Mars to be doing research there. So rather than sending spacecraft all the way to Mars, having it collect information and samples and bring them back here to Earth, the goal is that someday we'll have crewed missions that will do their crewed, C-R-E-W-E-D, meaning staffed missions, human-led missions that take place right there on Mars. But Mars is far away. It takes a really long time to get there, and we're just not quite ready. So this mission is part of what's going to help people get ready to eventually go to the moon. Now, the Mars Exploration Program in general has 4 science goals. They are to determine if there was ever life on Mars, to study Mars's past and current climate, so that's weather patterns over a long period of time, not just what's happening day to day, but really over years and decades and thousands of years, what is the weather doing? And also, what's the geology of Mars? So what does the surface look like? What is this planet actually made out of? What are the rocks like and the soil like? What's the stuff that is Mars? And again, to eventually prepare for human exploration on Mars. And NASA is using technology to meet these goals because, again, we're just not quite at the point of human missions, right? So essentially, we are sending machines to Mars to do these missions for us until we can get people there. Now, why did we choose Mars? And when I say we, I mean humankind in general. What do scientists all over the Earth? Because it's not just NASA. There are governments and private companies all over the world working on this. So I use the term we a lot, but I really mean the scientific community when I use that word. So why do we specifically focus on Mars? Well, first of all, it's our neighbor. It's the next farthest planet from the sun after the Earth. So it's still really hard to get there. It's still really far away. But in relative terms, compared to some other places in our solar system, it's pretty close by. It also has an atmosphere. It's a thin atmosphere, but it does have an atmosphere. It has, it's a terrestrial planet, so it's not a gas giant like Neptune that there's no real surface to speak of. It has a solid surface that we can land spacecraft and people on. And there are signs that a really long time ago, like billions of years ago, there was liquid water on Mars. And that's really important because as far as we know, there has never been any form of life that science is aware of that didn't require liquid water to survive. So if there was life on Mars, it was probably where the water is. And that's one of the reasons scientists are so interested in the geology and the climate of Mars over time, because it'll tell scientists where the lakes were, for instance, where the oceans and rivers were that are now just dry, and we just have evidence of the very distant past. So it helps to look at what conditions used to be in, as well as what conditions on Mars are now, so that we can look for the places that life is most likely to have existed. And I'm not going to linger on this slide, but I did just want you all to again be aware that Mars 2020 is the latest in an ongoing series of missions. So these are all missions over here that have supported the Mars exploration program, including Curiosity, which launched just about 10 years ago and is actually still up on Mars today, still operational, and taught NASA a lot of the things that it needs to know for Mars 2020. Oh, I'll move my face again. So this is a beautiful picture of the surface of Mars. Again, that's taken from the Curiosity rover. There's the tire tracks right there. And so again, the goals of the Mars 2020 mission are to look for evidence of past life, to learn more about Mars's geology and climate, so the rocks and the soils and the minerals and what makes up the planet and what the weather's been doing over a long period of time, and again, to prepare for eventual human exploration of Mars. So NASA is collecting information and samples with a type of lander called a rover. So a lander is a spacecraft that, as it sounds like, it lands right on the surface of Mars. And a rover is a kind of lander, or well, a lander lands on any planetary body, right? But in this case, it's Mars. And then a rover is a special lander that not only lands on the surface, but can move itself around. It drives around like a car on a road, sort of. So the Perseverance rover is the rover that is collecting information for Mars 2020. Again, it launched on July 30th of this year, so about a month ago. It's landing at a place called Jezero Crater on the Mars surface. And it's using a new way of landing that I think is really cool. So the thing is with this rover, with this lander, it is not like there's a scientist here in Houston at a desk using a joystick to land the rover. That's not how it works. The rover lands itself. So it goes through a process called EDL, entry, descent, and landing. And as it gets closer to the surface of Mars, first it hits the atmosphere and a heat shield on the spacecraft is going to slow it down. Then it gets closer to the surface and a big parachute deploys, and that really slows it down. But there are new technological advances, including cameras right on the rover, that are going to allow it to kind of see where it is and make adjustments in real time so it can land in just the right spot. And this is a new technology. I think it's really neat. So we're going to just watch a quick video about what's called terrain relative navigation.
We are in Death Valley testing terrain relative navigation, the new technology for Mars 2020. The terrain in Death Valley is very much like Mars. It has a lot of sand dunes and steep slopes. It's quite similar to the landing site that Mars 2020 will be going to. We're taking a copy of the system that will be on the spacecraft, and we're testing it in the way that it would be used during the flight mission.
Terrain relative navigation gives the vehicle the ability to figure out where it is. This is kind of along the same lines of what the Apollo astronauts did with people in the loop back in the day. Those guys were looking out the window and looking for different craters and other features on the moon that they knew of from the maps we had of the moon. So that way they could figure out where they are and figure out where they needed to land to be safe. So for the first time here on Mars, we're automating that.
What terrain relative navigation gives you is the ability to avoid hazards that you already know about. So large hazards, hills, craters, things that you've seen before. With the camera, we take images as we're descending, and we match pieces of the image to orbital imagery that we have stored on board. And if we make many of these matches, we're able to figure out where we are relative to the map.
If we didn't have terrain relative navigation, the probability of landing safely at Jezero Crater is about 80 to 85%. But with Mars 2020, we can actually bring that probability of success of landing safely at Jezero Crater all the way up to 99% safe every single time.
We don't have an astronaut that we can put on board Mars 2020, but we can put this system, this terrain relative navigation system, so that the spacecraft can figure it out on its own.
I could see it being used on lunar missions, science missions, as well as human missions. Future Mars missions, of course, Mars sample return, Europa lander, landing on a comet, pretty much everywhere you want to land. You're going to want to have terrain relative navigation.
All right, so just in case you missed this small detail, oh no, I've gone all the way. There we go. There's where I want to be, back in my spot. So just in case you missed this detail, when they were talking about orbital data, that means that there are actually orbiters, that's a kind of spacecraft going around the outside of Mars. And as they're doing that, they're taking pictures and making maps of the surface. They'll send those maps to the Perseverance rover, so it'll have a map of where it's going, and then again it will use the cameras on its surface or on the spacecraft to help really drill down into the details of the surface and make sure that it doesn't land anywhere that's too rocky or in a crater or in a canyon or anything like that. So it's really sophisticated. Just a couple of things about the Jezero crater while I'm thinking about it. There is evidence that that it held a liquid water lake 3.5 billion years ago. So again, this is really logically the best place to look for life. I think that's all I have to say about that. Let's oh, no, I did want to tell you that it might seem like a small detail to get a rover to exactly where it wants to land versus pretty close to where it wants to be. So with the, for instance, the Curiosity rover, it was able to land and it was pretty close to where it wanted to be to collect data, but it still had to make a commute, essentially. It had to get from the landing place to the data collection place. Same thing with the Perseverance, right? It's going to land somewhere and then it's going to go somewhere to collect the data. But guess what? This terrain relative navigation, this ability to adjust itself real time and to get where it wants to go, that can shave an entire year off that would just be sent transporting itself, driving from the landing site to eventually where it's going in the Jezero crater. So we don't want to land right in the crater. It's going to the crater, but it could take up to a year to get there, except that it probably won't because the rover knows where it needs to go and where's a safe place to land. So it's very efficient, amongst other things. Now let's move my face up here. So the Perseverance rover may look familiar to you because it uses the same basic design as the Curiosity rover. So the Curiosity worked pretty well. It has been up on Mars much longer than intended. It's been transmitting data for about a decade, not quite. It was a great design and they decided to replicate that, but they did learn some lessons that they used from Curiosity to improve upon the design a little bit for Perseverance. So if you want to think about Perseverance as being, if it were a living thing, right, then right here would be its head and neck. And that's what is called the remote sensing mast. So it's a mast, a post that goes up, and then right here is a camera. That's how the rover knows where it is, sees where it is, and then it transmits that data back to Earth via antenna. Also has drilling equipment here, so it can take geological samples of the soil and rocks on Mars, and also has equipment that it's hoping to learn how to convert carbon dioxide to oxygen on the surface of Mars, which would be important if we ever had human crewed missions. They would need to be able to use that process to get the fuel to send themselves back to Earth. Uh-oh. Okay, so just quickly here, there's another aspect of this mission that I want to talk about, just again, real quickly, it's called the Ingenuity Helicopter. So this is a little guy, it's about 4 pounds. It's strapped to the belly of the Perseverance rover, and when it gets to Mars, the helicopter will detach and it'll go about its business while the rover goes about its business. Now this is essentially like a side quest, right? It's not the main idea of the mission. It's what's called a technology demonstration. So they're sending this helicopter just to see if it works and how it works, and it's a really small scale investigation into something that's just getting started. So it's a learning experience. It's not collecting any science information. It's just to see from an engineering standpoint if we can do it, because we, meaning again scientists, humankind, all of Earth, has never flown a helicopter on another planet. And it's tricky because Mars has a very thin atmosphere, so it's hard to get enough force to lift the craft up into the air and to keep it going. And it also has really cold temperatures, so this thing has to be very well insulated. It's powered by solar panels, and let's see here. So if you look, there are 4 blades, 1, 2, 3, 4, and they're arranged in 2 rotors. These rotors are going in opposite directions from one another, and they're spinning really, really fast. So I think it's something like 2,400 RPM. That's a lot faster than an Earth helicopter would go, but it needs to go that fast to lift itself up in the thin atmosphere of Mars. So we don't know if it's going to work. That's the idea. Hopefully it does. Hopefully it doesn't crash. But if this works, then that will be really useful information that NASA and other space agencies and private companies can build upon for future missions. So eventually, someday, there may be helicopters flying over the surface of Mars and other planets and taking aerial footage, kind of like a traffic and weather helicopter here on Earth. So that's just something that we're really just in it to see if it works, and I'm excited to see if it works. So just really quickly before we end this, I want to encourage you to all take a look at the Artemis program. Now that is not directly involved with Mars, it's directly involved with the moon, but we're going to take the information that we use or that we learn from being on the moon and eventually use that on Mars. So the idea of the Artemis program is that it's going to take humans back to the moon, American astronauts back to the moon by 2024. One of these will be the first woman ever to be on the moon, so that is really exciting. And it'll be a series of trips to the lunar surface that get longer and longer. So it'll be a really quick one, and then a little longer, and then a little longer. And hopefully, eventually, the idea is that we'll learn how to set up a base on Moon, a lunar research station, and astronauts can set up shop there and do all of their work from that station. So it's about a 3-day trip to the moon. So it would be much more efficient instead of traveling back and forth every time we want to get a sample or learn something, if we could just have people living and working right there. So if we can achieve that on the moon, then the next step will be Mars. We'll use that information and technology and all of those things that we developed in the Artemis program to fuel future missions in the Mars exploration program. So keep an eye on Artemis as well. Okay, and if you want any more information, there's a lot of resources. You can always just type in NASA Mars missions, NASA Mars exploration, NASA Artemis. Those will all come up with the information that you want. But specifically, I did put the links here. So for Artemis, it's nasa.gov/specials/Artemis. For Mars 2020, or actually for the Mars exploration program, it is mars.nasa.gov. And if you have any questions, if you want to contact me or any of our staff here at the Discovery Center, if you want to see what our operating hours are, our current selection of planetarium shows, our upcoming events and programs, all of that information will be on our website, starhop.com. Okay, so again, I thank you all so much. Oh, I'd like to come back and be full size. Technical difficulties. All right, so thank you all so much for joining me. It has been a pleasure for me to share information about the Mars 2020 mission, about the Mars Exploration Program, and about all of the exciting space science that is happening right now all over the world, and of course all over the universe now, right? So I thank you for joining me, and you all have a great afternoon. Bye-bye.
I'm Kristen Sanborn from QA Cafe. We're so excited to sponsor the Maker Fest again this year. The Children's Museum is so important to us. As a local tech company, we're always interested in ways to give future engineers the experience they need and to have fun with it. So have a great time, everyone, and come back next year. Bye.